All right, so it's 2 o'clock. Let's just go ahead and begin the video and the stream. So last time we left off, more doing some more of the documentation, trying to get all that started, caught up. Looking at the PRD, uh, starting some of the test plan writing and stuff. We'll fix all this, update it as we go to meet more reality. Again, I'm using Copilot to help write some of these. It's just for one thing, it'll keep everything formatted the same, similarly, and keep all this very similar from document to document. What you want is consistency when you're doing any kind of documentation for projects. That way, everything's in the same spot. An auditor or a customer or whoever can look in and say, okay, well, here's where everything is. Everything's going to be in the same spot from document to document. So one of the things I've also noticed is it's going to be easier to write some of the tests from the PRD once we get a little further along in the schematics. That way we can actually write the tests with like test point one, test point two, places where we should actually measure from. So everything's gonna be hand in hand. We'll be doing documentation as we design, as we do other things, as we lay out. We'll be able to do better test plans and documentation. So it's kind of a process that all kind of flows together. So one of the things I do want to cover before I get too far into this is I've mentioned contract design and manufacturing. A few essential skills I would say important with contract design and manufacturing is first, learn to manage customer expectations. Don't promise things, don't promise deadlines, don't promise features that you can't meet or accomplish. Promising them and failing to deliver are some of the worst things you can do for yourself. They're some of the worst. That opens up legal liability, that opens up a loss of reputation, a loss of credibility in what you're trying to do. Bad news, bad information about you spreads faster than good. You just have to remember that. So the better you manage your customer expectations, the better off you'll be in the long run. It's better to lose out on a job through the quoting process by being honest about it up front than to bury yourself into a problem that you can't dig out of a hole. That is the worst thing you could do to yourself. Take it slow, do the jobs you know you can accomplish, be realistic in your timelines, your deliverables, all that. That will build up credibility faster for you than any accomplishment ever could. Also, another thing I would suggest to manage is what I call the easy demon. Uh, it sounds funny, but I have seen this and named it such because I've seen it happen with other companies, with other projects. I call it the easy demon because what happens is somebody presents a project for you to do, and oh, it looks easy. Oh, that's an easy project. Oh, it's a simple project. I can do that. I can accomplish that. It's easy. It's only a handful of parts, a simple board. It's not even digital, it's pure analog. It's a very simple project. It's easy. Those are a trap. Beware the easy demon. Even if it looks to be an easy project, an easy thing to accomplish, approach it with the same diligence, the same care and attention that you would a more complex project. Because easy projects can snowball and go out of control real fast. Overconfidence is very dangerous, especially if you're working with certain customers who have deadlines to meet, who answer to other people. So another thing I would caution on the subject of contract design and manufacturing, be aware of what you're doing and who you're doing it for. If you're like the first party involved with a direct customer, so customer company A comes to you and says, hey, I want you to do this, and you're involved in it top to bottom, start to finish, great. Uh, You understand all the requirements, you've talked to the customer, you've documented everything they need it to do, everything they want it to do. You use project management skills to manage scope creep and everything. The real complexities come into play when you become a subcontractor. So what happens is company A goes to company B for a specific project. Let's say a hardware project that involves electromechanical devices. But company B needs a control board built for this electromechanical device. So then they turn to you for the electronics, for the control board. Now you're a subcontractor of company A. Well, you're a subcontractor of company B, but at the end of the day, you answer to company A. So you're company C, who at the end of the day answers directly to B, but also to company A. Sounds confusing. One of the things you have to be mindful of something called a flow down requirement. So what these are, so company A has, let's say they're doing something government related, something military related, something medical related. They have to follow specific regulations. They have to follow specific laws, things like ITAR compliance. Let's take that for example. And what this does is it creates a flow down requirement. So not only does company B have to meet these requirements, company C, which is you, also have to meet these requirements. You have to make sure that anything you take on through a subcontractor type role doesn't involve a flow down requirement, which could ultimately land you in trouble. Because sometimes company B can act in your defense and act as a shield, but depending on what happens, sometimes company B cannot. And you open yourself up and expose yourself to liability. That's another reason I stress documentation. Document as much as you can. Make sure you and the customer know what you're getting into. You agree to everything. Things are outlined. Uh, your deliverables, you know what you're going to be giving them, your timelines, everything. Just do your due diligence. These are the things that will hurt you faster, will destroy your business faster than maybe not designing something properly and having to do another board spin. If you don't manage customers' expectations, if you're not monitoring for other requirements, flow downs, those are going to hurt you worse than saying, oh, hey, we made a design mistake. We need to build another board. We need to order more parts. That's kind of expected, especially when you're designing something from scratch, when you're coming from the ground. That's expected. That happens. That's the way the process works. But if you make mistakes in managing other things like your requirements, your expectations, and everything else, promising things you can't deliver on, that's going to hurt worse. That's going to cause more problems. So I'm trying not to scare anybody out of doing anything, from taking their ideas and moving it forward into a product you can realize and put on the marketplace, or step into contract design and manufacturing. But don't overlook those things. Those will be the destructor of you. You have to take care and mind the paperwork. It's not all design build. It's also documentation. It's also covering yourself, making sure that you're going to be protected as best as possible in the event of a problem. So with that said, we are going to go ahead and start jumping into the schematic capturing based off of the product requirements document that we formed and the block diagram for the device, the initial block diagram, which kind of gives us an overview. So for that, we're going to be using KiCad, but first we're going to come into Odo, where our project management is, and we're going to go ahead and drag the capture schematics over to InProcess. These two will kind of be going hand in hand. The create test requirements documentation, that will probably continue on until you're pretty much at the point you get the pilot board pretty much built, and maybe even start doing some testing, and you realize you need some more test documentation or fix what you've already created. So this is going to be kind of a continuous process. So we're going to capture the schematics. So we're going to be using KiCad. I've never really used KiCad too much, so I'm going to be learning just as much as you. And if you already know KiCad, you see mistakes, you see errors. I'm not opposed to constructive criticism, so don't be afraid to let me know. Where I made a mistake, just be polite and respectful about it. I prefer to use Altium Designer for my professional work at Sanctuary Software. For my own work on my own time, my own side project, I use Circuit Studio, which is also by Altium. It's basically Altium Designer's little brother. Has a lot of the same features, a lot of the same capabilities, and I've grown to really like using it. I used to use Eagle uh, before Autodesk bought it out, and a little bit afterwards, but I grew to love Circuit Studio. So KiCad is new to me. The reason I'm really going to use it is to kind of help out anybody who's just getting started into this, who has an idea on a breadboard, and we can learn together. So imagine we start the schematic editor. Create, open a project. Okay. All right. File. So we're going to start a new project. All right. I hate having to show all this stuff, but that's fine. I don't really care. Documents. We can always edit it out. Okay. So it's going to be a new project. So we're going to want to put it in the hardware folder. So we're going to name the project file, the KiCad project file, the same thing as the actual folder, pretty much. 101, 22, 02, 501. We're not going to version the actual file name. We'll handle all the versioning inside. So let's see. If you hear purring, that's my one cat, Henry, that likes to hang out on my desk and help me out with design work. So we'll just name it the same thing as the folder. That'll be the KiCad file. All right, so we have the schematic here and the PCB. All right, okay. So we'll start with the schematic first. All right. Okay. Okay. Like I said, I've never really used KiCad before, so this is going to be an interesting learning experience. So, Rev, do we have to put a number there? Maybe down the road we'll get into finding ways to customize this. In Altium and Altium Designer and Circuit Studio, I'm able to basically create templates to where all I do is go in to change a parameter file, and it can populate all these for me with parameters. So let's see here, preferences. I'm just going to check this stuff real quick to see if there's any symbols. Now, we're going to assume that. All right, so I probably will have to put a text field into there. I prefer multi-sheet hierarchy. Okay. All right. Yeah, so bear with me. Okay, so not labels. We're not doing not labels. Draw text. So we're going to call this schematic sheet. So we're going to start with the a lot of times what I consider the more important part which are the power supplies. So power supply. I don't know what that means. Okay, where's it gonna put? Aha! There we go. Yeah. Okay. Okay. All right. Okay. Power supplies. There we go. Perfect. Beautiful. Color. Wow. Black. There we go. We're going to fix that. So we're going to go to preferences. Preferences. I prefer to work in metric millimeter. So let's see if we can go here. Well, we're going to stay in mils in the schematic editor, but when we go to the PCB editor, we'll go. We'll use metric. Looks like it's already metric in the PCB editor. Footprint editor. We will figure all that as we go. All right. So for the schematic, you want to tend to stay imperial, stay in mils, because a lot of the schematic symbols are done originally in mils. And it's just easier to stay in mils. But when you go over to the PCB layout, a lot of components are designed, their footprints are designed in metric. So it's just easier just to work in the metric scale. So I'm going to tell you right now, we don't have any parts in our library. We have nothing in our library. You typically don't in the default library. You may have like resistors, generic resistors, things like that, but we're not going to go with generic resistors. So let me figure this out here. So let's go back to here. Footprint libraries, symbol editor. Okay. So the way I prefer to work, so I've noticed with my initial testing of KiCad, every part has its own library file. I don't like that. I think that's like the hardest thing to administrate. And when you're trying to pull in parts to do a design, to go through and select, oh, I have Texas Instrument parts over here. I have advanced, I have analog devices over here. I have Yagyu, resistors over here. I don't like doing that. I like keeping it simple with maybe 3 library files. One is for all your general parts, one is for connectors, and one is for like logos. Well, a lot of times what I've noticed is, well, yes, you can inject a logo, a graphic file directly into the PCB editor. You can actually make it easier on yourself and create a footprint out of it. That way you can just drop it in, and that's what we'll do in the long run. We'll just do some kind of generic logo. We'll just throw something together. Or I'll just use our logo for the Magic Forge. So let's see here. Symbol editor, global and or project schematic symbol libraries. So how do you add a library to here? File, import. Nope. Edit, view. Yeah, I like Altium because you can actually pull in your libraries. Symbol editor. Yeah. Oh, does support design blocks. Manage symbol libraries. Let's see what we got here. Yeah. Okay, so here's all the built-in symbol libraries. Yeah, they're cool. But now you got to go select all that. You got to jump through all this to find different libraries. Let's see here. MCU. There's ST, Silicon Labs, Microchip. Let's see if there's I bet you there's nothing here for the ESP32. No some. Yeah, yeah. So we're gonna go through. We're just gonna. So we're gonna create a new library here. All right. So we're going to. Okay, that's a global library project specific. We're just gonna use global libraries. So we're just gonna. Let's just get rid of all these. Yeah. Bye. Bye. Have a nice time. So yeah, imagine having to try to jump through all these to find one part. It becomes a pain in the rear. I don't like it. I hate it. I hate it. And it becomes an administration nightmare when you're trying to do version control. When you're trying to maintaining a central library is a lot easier in the long run. This is a horrible way of doing it. It really is. It's just a lot of hoop jumping through just to find one part. We just have central libraries because they're easier to administrate, they're easier to version, they're easier to control. Okay, so there's no library. So what we're going to do is we're going to create a new library. I think we do it through here. What's this here? New project. All right, so here we go. Let's see if we can figure this out together, my peoples. File. Save. No, it's a library. Let's see here. Oh, new library. Okay, we're going to add it to the global library. All right, so here we go. We're going to create a new library. Oh, it's annoying. Okay. Yeah, I hate having to do this, but like I said, we're learning it. Okay, so KiCad, we're in a library. We're going to call this one um, uh, this is called components. All right, there we go. So we have a component library. Now, we're going to see how annoying this is going to become. We really are. Because I have a feeling this is going to get really annoying really fast. So we know the ESP32 is not in there. So we know we're going to use the ESP32 room 32 UEH4. Right. Let's make sure UEH4. H4. So we're going to go here. And they don't have any in stock. Let's see. Expected November 3rd. Oh, expected tomorrow. Wow. I can't believe that they are out of stock on those. Let's see if they have ESP32. Let's go here to just look at the room 32. We don't want one with internal antenna, so internal antenna would be nice for Bluetooth and Wi-Fi. I prefer using external antennas because it's going to be an enclosure. That way you can use a bulkhead. All right, here we go. The N8. Let's see here. Bum, 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 bum. Flash. Maybe just use that one. Let's see here. 528. Wow, these prices jumped up. It's 4 meg spy flash. All right. So let's just make an executive decision. Let's see here. 4 meg. 4 meg. It's got 16 megs by flash. Blah, 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 blah. Let's just go with this fella right here. Okay. All right. All right. So we're going to go with this guy. So let's just go ahead and that. Back over here. I hate that. I hate that. Room 32 UEN16. There we go. All right. So one of the things I like to try to do is to see if the footprint and the schematic symbol are already in a manufacturer supplied model. So we're going to download. So here's the schematic symbol, the footprint, and the 3D CAD file. So download CAD models. So you may have to create an account to be able to download, which is no problem at all. It's all free. So it's going to download it, save it in my downloads folder. Right here, we're going to extract all. Now, okay, 3D. KiCad, all right. All right. All right, so there's a symbol file. All right, let's see if we can open that. I'm going to copy that directory, come here. File. All right, let's see if we can figure this out here. Import symbol. Oh. All right. Okay. Again, I'm just now learning how to use this. All right. Get rid of that text. All right. Okay, this is gonna get annoying. Like I said, we have a lot to learn. All right. How do I get rid of it? Use symbol properties dialog to remove fields. Symbol properties. Module. Okay. Description. Okay. Okay. All right. So this is good. Okay. Footprint files. All right. Embedded files. Okay. Okay. So one of the things we're gonna need to tackle now, and I want to get started on it before we get too far ahead. I know I said we are going to start on the power supply. I should have chosen a power supply component. Um, you know what? Let's tackle that first. So we're going to stay there. Okay. It's just my brain doing my brain thing. So we're going to use the AP. So this is a power supply, a switching power supply. We're going to be feeding 12 to 24 volts into this unit. So this guy right here, these guys will be perfect because you need for the motor driver runs off of 12 to I think 48 volts if I'm not mistaken. But we're going to keep it constrained to your typical automation power supplies, which is going to be 12 to 24 volts DC. So that's what we're basing everything off of. So AP. So let's go and get rid of my but first syndrome and go to where we're. So we're going to do the core part of the switching power supply, which is that unit. We're going to do the 3.3 volt first. AP 6320. Bump. 3W7. 3W7. All right. Thankfully, we don't have to create a footprint by hand, I hope. We're going to go ahead and download this. So we should already have it. What we're going to do is we're going to. I love Windows 11. Do this. Downloads. There we go. Extract all. Do we have a KiCad? Yes, we do. Yeah! This is going to make our lives a little bit easier. So we're going to go back to KiCad. New symbol. Maybe can we? Okay, we can rename. Okay, so we're going to File. We're going to import symbol. And then I'll get into what I'm trying to get at. Aha! Perfect. 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 So we have our essential components library. All right, we're going to clean all this up. I don't like having that there. All right. Okay, so one of the things I want to cover are naming schemas for your library. It'll get more important when we get to passives like resistors and capacitors, and I'll explain why. But when you're doing standard parts, sometimes it's easy to have a naming schema that you want to stick to maybe help find stuff. So you have a filter here. And you may not know exactly the part you're looking for. So we click here. I don't know why it's not showing up there, but maybe it'll show here. Yeah, okay. Shows up these properties. Okay. So what I typically do for my projects is for my libraries, I have a naming schema I use, and I'll share it. So for this is a power management, so we're going to rename the symbol. We're going to leave that the same, but we're going to say PM for power management. And the reason is any IC for a power supply, be it linear, buck regulator, buck boost regulator, anything that involves even a shunt regulator. I'm going to prefix the manufacturer's part number with PM for power management. That way I can go up to a filter and say PM. And it'll bring up all the power management parts that I have, and I can go through and click on them and see what I have. So that's something I do. We're going to continuously go through this and add parts in this manner. We will write a SOP or work instruction to handle this later once we settle in. And what we want to do is just easier to go ahead and kind of do all your skeleton framework now, and then add that stuff later. So I'm gonna use a notepad, a sheet of note paper. You know what? Let's do something a little bit more fancy. Let's bring up. Um, let's bring up. Uh, you know what? Let's just actually just add it here. Let's see, hardware, QMS. Because we can rename things that we need. So let's just keep it together with this. We're gonna call it an SOP because we're gonna add other things to the SOPs. New file. We're gonna call it. We're not gonna fix it right now. So we got a parts naming convention. So we're gonna say I see. Again, we'll formalize this and actually create a document number, clean it all up, and add it to the master documents list and have it all nice and version controlled down the road as we go. But this is going to create the framework that we can build off of. Prefix PM. There we go. That way we have a note and we'll keep adding to this as we go. Back to KiCad. Now, I don't know how KiCad works versus Altium, but we're going to come here. We're going to go into civil properties. Okay. Now, if this works similarly to Altium, we're going to want to clean this up and fix this and stay consistent. Can I make this window bigger? Yes, because another powerful tool we're going to use for now. All right. So it looks like these are okay fields, and chances are these actually get translated over to the bill of materials. So let's see. Let's get rid of that one. Let's get rid of that one. We want to keep this some of these. Looks like we can move them. So reference, that is the part reference. So it'd be like IC1, IC2, IC3. You know what? That works. We'll keep that. Value, that is, okay, that is an internal part number. Can we edit any of these? Doesn't look like we can edit any of these directly. So we have to kind of create our own. Okay, well, we'll just have to understand value is going to be an internal part number. That's going to be annoying, but that's fine. The footprint, we'll probably have to go through and fix. Okay, so it looks like here's. Okay. All right, we'll have to fix the footprint library. Okay. All right. Okay. Okay. Perfect. 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 Data sheet. We can keep that, but bye. First 5 fields are mandatory. What in the world? All right. 1, 2, 3, 4, 5. So that's a mandatory field, apparently. Okay, so it looks like we can fix those. All right. Okay. It's going to get annoying. So let's see what this guy says. Switching voltage regulators. Does that match? It does. But we may want something. Okay, temper tape reel. Let's clean this up. Also, you want to formalize descriptions. That way, when you enter them into the BOM system, your parts library, we'll be doing that too. We'll be adding this to Odo for the parts library and things like that. But let's get one thing at a time. So description. Let's see. Switching voltage regulator. We'll just keep it simple at buck. So one of the things we'll also want to track is 3.8 to 32 volt input. Input at 2 amp. Output. Some other relevant data you're going to want. You can put the single output if you want. Do that. We'll put one channel, positive. So one of the other things we're going to want is your temperature range, because that can be important in designing. So -40 to 85. We want to put that in here. -40 alt 0176C to 85 alt 0176C. And then it's a Rojas part. So I'll put that in for the description. Now, Mauser's not going to be the only company we use. The only vendor. We want to be able to have options. But they're going to be the first ones. So I want to say we should simplify this. We're going to call them so. Vendor 1A part number. We'll just keep this to manufacturer 1. Manufacturer 1. And then we're going to put vendor 1A. Because when you create a BOM, and I don't know how KiCad will create a BOM, if it'll export a bill of materials, but Altium, all these fields can get carried over, and that way you can populate a bill of material spreadsheet like real easily. We're also going to put vendor 1A cost low volume and vendor 1A cost high volume. Now the reason I'm doing 1A, so manufacturer 1 is Diodes Incorporated. So if this were a part that has direct drop-in replacements by other manufacturers that do the exact same thing, that have the exact same specs. Let's say ST Micro had a buck regulator that could drop right in here, do the exact same thing, exact same pinout, the exact same specs. You could change that here. So manufacturer 2 would be, ST Micro, manufacturer 2 part number, and then vendor 2A. So this vendor 1A, so that is Mauser associating with manufacturer 1. It's confusing at first, so let's see our low volume and our high volume cost. Low volume, so 71 cents. One. So high volume. I consider anything around 1,000 parts to be high volume, even though a full reel in this case is a 3,000. But I always look around 1,000 because it seems to be very typical, and it's just easier because the real quantities are always different. So I always, like I said, always look around 1,000 to be considered high volume. 342. So that's your high volume cost. So we have our reference, that'll be IC, or internal part number, the footprint, which we'll link to here in a minute. We'll fix this once we get the footprint library going. All right. So we're going to OK. We're going to save it. Jesus criminy. Can I move that? That is kind of weird. So it won't be visible. It hopefully isn't visible. All right. This is just so weird that it. I mean, they're fields. What in the world? Okay. You know what? Show field name. Okay. I mean, who knows? That might help. Show field name. Who knows? This is all new to me. Show field name. Hey, okay. I mean, just go ahead. Let's just do this. Okay. Huh. I'm going to. I like this over here. Okay. Before I get the footprint done. Oh, yeah, I can move all fields together. Okay. So. Okay, I don't like the way this is laid out, and I'll explain later as we go, but for now, we're going to clean all this up and change the way this looks. Let's kind of open this up a little bit. Okay, feedback. Where do I grab that to move it? All right. Okay. I know it's crazy, but if KiCad works the same as Ultium, the way the pins are organized here on the screen don't matter as long as their designator, pin number matches properly to the footprint. Then it'll line up properly in the actual PCB layout. So I'm just going to assume that KiCad works the same. There are reasons for what I'm doing, and it sounds crazy. It seems crazy. So, all right. So enable. Just put that down a little further. Let's get the ground out of the way. Oh no, okay. So how do I rotate this? Okay, so R. Okay, so in Ultium I can use the spacebar to rotate. So I have to remember R to rotate while I'm holding and dragging. Okay, feedback. Okay, so this is your switching output. I'll drop that down a little bit. That's your feedback input. So that's what tells the device that it is actually putting out the voltage you want. Okay, your boost, there's generally a capacitor that'll connect in there. Let's do that. It'll make more sense when the schematic actually gets captured, when we actually capture it all. There. Put the part number here, I guess. A lot of times, I like putting the part number below. All right, so we're going to save. Okay, now that we've got that going. All right. So we're going to go here. Footprint editor. We're going to go file. New library. Global. We're going to put it here in the same folder. And we're going to call it components. So we have file. All right, so we have the components library. Oh my fucking god. Is there a table? Manage to put libraries. All right. Okay. Let's just get rid of all these damn things. Come on. Bye bye. Bye bye. Am I actually deleting them? There's just that many to delete. Can I shift? Oh. All right. All right. I can shift select. All right. Bye. Have a nice time. Okay. Boom. So now we're back. Okay. Perfect. Perfect. All right. So now we're going to go here. So we're gonna import that footprint. File, input footprint. Okay. We're gonna go here. I think it's this guy. Oh, all right. Beautiful, beautiful. All right. So another thing we're gonna look at is the layers here. Okay. Front courtyard, back courtyard, silk screen. All right. Okay. Jesus Christ. So that'd be your silk screen. How big are you? I think we can change. Hopefully, we can change this in the actual PCB layout. We'll figure out as we go. So there's that. So what are you? Fab. All right. Okay, so here's okay. Again, we'll come through and clean this, fix this as we need to. All right. Let's see. Is there a 3D viewer? Okay. Oh, okay. That's freaking awesome. Okay. Good. 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 All right. So we're gonna want to place. Is there a 3D body? Can we throw a Save in library. That's the footprint name right there. We can always fix it later. Okay. Okay, good. We saved it into this library. I want to see if I can place a 3D body here. I wonder if we can do it here. If we do it here. Oh, let's see. Yeah, I want to figure out how we can add the step file. Tools, insert, place. View, file, edit. Different properties. 3D models. All right. Oh. Okay. Does it have to be? Will it be embedded? Let's go up here. Does that step file have to stay with it, or will it get embedded? Save it. We're going to view. Okay, that looks sexy. So that's the first footprint in our components library. Okay, and not a whole lot different than Altium and Circuit Studio. It's going to be some getting used to, so I will flub around a lot, especially when I see how everything's going to look like on a PCB. So I guess then we go over to the components. Okay, that is going to be a problem here. Some properties, I wish I could double click on it. So we'll go here, footprint. All right. Okay. So that should give us our IC. Okay. Now let's see here. Let's see here. Passive. What does that? Okay. I want to see the pin. Okay. Local type. Power input. I guess we can change. Let's see what that does. I don't know what's going to do, so I'm going to leave it passive for now. As long as it doesn't show passive and all these words in the actual schematic, I guess we're fine. So here we go. All right. Okay. So we have the core regulator, the 3.3 volt regulator. Let's pull this back up here. Told you this is going to be interesting as all heck. All right. All right. So we're going to save that. We're going to just leave these windows open. Come back to our power supplies. Now we're going to, how do we insert parts? For editor. We don't need to edit anything. We need to, oh, okay, generate bill of material. Cool. Switch to PCB editor. Okay. Beautiful. We'll figure all that as we go. Preferences and symbol libraries, components. Okay, so here we go. Oh, no, that's not doing it. All right. How do we add a symbol? Double click. Place. So, A. Okay. Okay, so we have our first symbol. All right, hooray! We've got our first symbol placed. Aha, yeah, all right, cool. Now, can I go in here and, yes, perfect. Oh, this is beautiful. Okay, all right. Like Ultium, I can drag this stuff around and clean things up. Okay, so I hit A to add a symbol. Okay, okay. I'm at, oh, maybe it's over here. Place power symbols. Ground. Oh, don't tell me I deleted the power symbol library. Do I need... Wait a minute. What? Wait, what? So did I accidentally delete the power symbols? Okay, so we're gonna have to probably create new symbol libraries. Is there a way to edit the power library? Is that actually a thing? Kind of ridiculous because in Altium and even Eagle, they're universal. You shouldn't have to add it as a symbol. It's kind of dumb. Place power symbols. Okay, that's kind of stupid. That you can actually delete your power symbols. Okay, let's see here if I can fix that somehow. Uh, yeah, I will work on fixing that for the next video. I'm just gonna go ahead and stop here. I gotta fix that, figure out what mistake I made. I'll fix that real quick, and then we'll pick up the schematic capture. But we have our first part in here. We've started the schematic capture. So we started creating our library files. We created our first schematic symbol where we didn't create it. We just imported one that was already created by the manufacturer. Those are usually the best way to go. We just modified it to suit our design flow and everything like that. So we'll pick back up and catch you in the next video. Thank you for watching and have a good weekend.